So to get the water out of the far back, I'll stick the vacuum in here. These blocks are for kneeling on. Don't poke your eye out and this bolt sticking up. And feed the hose all the way back there. Balance the camera there. See if that'll work. Gonna get loud. So the small wires bring up everything to the lower section, which is parallel at 12 volts, and the large cables go up to the large switches. Each one has a fuse, and that puts the 4 batteries in series for 48. Here's the solenoid that allows the 48 to flow to the motor controller. Sevcon Gen 4 motor controller, 48 volts. There's all the control cables. And 3 phases go to the stepper motor. This is the throttle connected to the original throttle cable from the cockpit. This switch from Thunderstruck, along with these other things. This is the junction box for the kill switch, so that switch runs to this white cable, runs to by the throttle control outside. So there's a kill switch outside, there's a kill switch here. Push off basically before you stick your head in here. That turns it on. We're not going to run it right now, but a couple of places to isolate the basically 24 volts that activates the solenoid is what happens. So these 2 kill switches and the key switch are the 3 places to, and all 3 have to be on to energize the system. And what else do we have going on here? So the interference that I had was the CAN bus to the, what's that thing called? To the Sevcon Clearview display. And these wires in here are the Sevcon Clearview. And I had to twist the pairs. I twisted the power pairs as well. The red and the black are the voltage for the key switch and also for the display. Actually, the key switch might be this one, but they all run up that way. This might be the key switch. I forget. They all run up to that same panel where the Clearview is, but the CAN bus here was the important one. The green wire you see there had to be a twisted pair. That's where all the interference was coming from. What else? I'm not using a heatsink. I just have the metal back of the motor controller exposed to the air by hanging it down. into this open space here in the engine compartment. Haven't had any trouble with overheating yet. And all those cables run through up here to this little arm, so I can swing it outside. And the key switch and the Sevcon Clearview are mounted here so I can access them in the cockpit. The other side of the panel looks like this. So the top switches 24, 36, 48 volt. When you turn those on, you go into series. Everything's fused on all lines. If you mix this up, it pops a fuse instead of melting things. It will melt the contacts inside these switches for the 12 volt parallel. I have destroyed one switch with a mistake. So you can see the top ones. I used these removable keys. So basically you have to insert the key and turn it in order to go to 48 volts. So right now I'm in parallel at 12 volts on all 4 batteries, and that allows this charger to charge both the main bank, and then the second one is on a house battery. Pretty simple. This was a late addition to add the Shore Power Charge Pro charge controller here. And I am using it incorrectly. It does say not to charge more than 1 battery in a bank, though, so I've got 4 in parallel, but I haven't had any problem yet. But what I was looking for was 20 amps total, so Shore Power is 30 amp, so I wanted to be well below that. And then on each bank, 10 and 10. So 10 is overkill for the house bank, but 10 amps on the 48 volt system is basically 2.5 amps per battery, and that's all I was getting before. I was using another charger that could charge max of 10 to 12 amps, so I wasn't charging any faster than I am with this one. And when I look at adding solar or something else as a solution, I'm probably only going to get 2 to 3 amps into each battery. So it's just a matter of coming to understand how long it takes to recharge and being open to that. Not very much happens fast on a sailboat anyways, so you just go with it the way it is. So I will say something about how the engine is mounted in here. I used the chain coupler that was provided by Thunderstruck motors, and that allows for misalignment with the shaft as well as ease of installation. Just a couple of set screws, one on each side. I'm using the mount provided by Thunderstruck because this lower part, that part, the black part there, that's a thrust bearing, so that handles the in and out forces that the propeller puts on the shaft. So that comes into this lower pulley. This is a normal automotive timing belt, so easy to replace. Up to the top pulley, so 2-to-1 reduction on the electric stepper motor. It's the 10 kilowatt, so it's basically nominally 50 volts. So it's limited, and it's software limited in the controller is what I've noticed, to 200 amps. And that limits the speed. And I'm okay with that. And then I added these braces to the top section just to take out some of the vibration that can happen in the motor. But otherwise, everything that's bright silver color came in the kit except for these 2 bars that I added just to brace the top. And then this lower part, these are the original motor mounts from the diesel. I left those in place because they have some issues with the in the bed. The bedding rails for the mount, there's some rot or something in there that doesn't make the bolts work great. But I've set them in with epoxy, and they're holding for the purpose now. And it doesn't need a lot of vibration damping anyway, so I just stuck with all the old mounts and everything. And then just put these steel runners on top. Clearly they still need to be painted, But steel runners on top gives me some adjustment, same adjustment you'd have for the diesel basically for alignment, and then that chain coupler takes out the rest of the alignment concerns. And there's the bank of 4 batteries again, where the old fuel tank for the diesel used to be. Pretty simple and very effective.